All right, y'all, I'm gonna just record a tutorial for the homework 2 in Dr. Tuan's FEA class. He went through it in class, but it's pretty fast. It was loud in Lincoln, so it's hard to follow. So this is just gonna be me repeating what he had. The video I had initially was too large, or the video that I got of Dr. Tuan doing it was too large, so I'm just re-recording it since I have to do it anyways. So just going to start off with preprocessor, add element type, and this right here, we're going to go beam and go 188 is, I believe, the way he defined it. Yeah. So we'll click apply. Okay. Oops, and that added 2. Delete one of those. I'll delete both and just add it again. Okay. So then we close out of that. Also forgive any pauses or awkward edits. I'm kind of just doing this along with the video. So I should probably just pause the video. All right, so something that I missed is that we have to go into here for options, and you're going to want to choose these settings. So initially it's on function of stretch, but we're just going to want rigid. We're assuming small deformations is what he said. He also chose the element behavior is in cubic form. That's indicative of like the equations that he was showing for like the beams. Again, not great explanation, but and shear, we're only going to want transverse due to it just being 2D is, I believe, how he described it. And then this one is fine, just like that. But yeah, you're going to want to have these settings for your element type. So yeah. All right, after you have your element type, you're going to want to go to your material properties, and within material properties, you go to material models. Again, this is kind of a repeat of what we did with the truss. But you open up material models if it opens. I just had another window open. If you open up material models, you go to the structural, linear, elastic, isotropic, and you enter in 3.605 e to the 6th for our Young's modulus. And then since we're working with concrete, not steel, our Poisson's ratio is going to be 0.22 instead of 0.3. Supposedly, we could also just put a 0 in here. I don't know if it matters, but this is what Dr. Tuan had, so. All right, and then after that, you're going to want to go to sections, beam, common sections. And with this, I already started this one. So for ID1, you're going to want to name it the member types that are in the drawing. So I think this one's ADFB. His video initially had a typo. I think it should be ADFB. But yeah, and then base is 11.583. Height equals 23.16. And then once you're done with that, hit apply. And you can go to ID number 2 and it should clear the rest. And yeah, continue on from there. And then for ID number 2, you're going to want DE-EF. We're just lumping these two together because they have similar geometric properties. I believe that says 13.76.16. And this one right here is going to be 26.32. They're just double. H is equal to 2b, so yeah, that makes sense. And go there. Make this number 3. And then for number 3, we just have one element type. I believe that says FG. We've got, sorry for zooming in on my forehead right here. 12.45. 5, and then this is 24.89, and hit apply right there. And then for ID number 4, we've got element, I don't know if that's a CG or GC. I'll double check real quick. So just double checking. We've got we've got GC, which is the one that we're doing. So now we can go back to this ID number 4, GC. That's 10.466, I believe, is what he puts. And so about double that. That's going to be 20.9 something. 20.9. He cuts it off right there, I believe. But yeah, 20.912, I believe. We'll just stop that right there. And now with this, you can press OK and move on to the next part. All right, I just wanted to correct my ID number 4 right now. Number was actually incorrect. So for ID number 4, we can go to this, I believe. Yeah. So I misread that. It was 10.166, which then makes 20.233 is, I believe, what he had. So we can click apply and click OK there and move on to the next part. And just to show you something that he did in class is go here, list properties, section properties, and then we go to this list and we can see that we've got section ID number 1, which we had. We've got our IZ of 3000, which is, according to this, well, I guess what's the name of that one? So that's ADFB. So AD and FB have 3 IC with IC equaling 1000. So that just calculates all that by itself. Additionally, on top of that, let's go back to this. It calculates your area for you. So we're not given actual areas. That's a question that was asked in class. And that's important for frames, obviously, for axial forces and whatnot. But it just does it for us since we were given these dimensions. So as you can see, you've got all these. We double check, but that's about 5,000. That's 4,000, and that's about IZZ for that one is a little bit odd. So I'll double check that one real quick. All right, I apologize, folks, but I was actually initially correct the first time with my dimensions. So as you can see, IZZ is about 2,000 right now, which matches what is shown in the drawing to IC, which is about 2,000. So if we go back, I can show you exactly the parameters I put in. So we'll go back to common sections, go back to number 4, and you can see that H is 20.933 and B is 10.466. So yeah, I was pretty close the first time, still a little bit off. But yeah, so we should be good with that part right now. Right, and now we are to the part where we are just going to create our nodes. So again, in the draw section, you might be familiar. We go to modeling, create nodes, and then inactive CS or something. I forgot what that was called. I also realized that y'all might not be able to see my my other screen up that I have right here, since I'm only sharing this screen via Zoom, which I'm screen recording. But so you probably didn't see the drawing that I had just shown in the previous section, but I've got it pulled it up right now so we can start putting in our node information. Again, this might be pretty straightforward. I've just got it pulled up right here. He actually gives us the actual node information, I guess, in, let's see what this file name is called. CIVE849 homework 2 ANSYS model.pdf. So that's under the assignments tab. I'm pretty sure if you just click on the actual assignment in the assignments tab, he's got 3 attached documents, and this is one of them. On, I think this is page 3 of that document, you'll be able to find what I'm looking at. So we got this, we got 480, and back to 144, we've got that like little pentagon shaped roof thing going on. So that was node 4, we're on node 5. But this is also at 480, and this is going to go to 0. Yeah, because this is element FB, if you know what I'm talking about. Element 6, we go to 840, and 840, we go 144, I, and then element, or node 7, last one, this is going to be GC, I believe. So you go right here, you go to apply, click OK, and we've got the shape that we want. We've got the like little pentagon shaped roof thing that we've got, and the little square off to the side. So yeah. So now we continue on with element attributes. Again, in the grade tab, we go to elements, go to element attributes. And with this, we are going to define our elements in a certain order. So if you go on the next page of the document that I just mentioned, that's in our assignments tab, page 4, Dr. Tuan laid out what the member number is and what nodes it's going to go to, like the starting node and the ending node. And so he in class did this in a specific order. So I'm going to also do it in that same order. So right here, we're going to start off with section number 1. And with this, we are going to go to, what do we go to? Double check real quick. Right here, we go to auto numbered through nodes, and this is just going to allow us to select node number 1 to node number 2 and click apply. So that creates that member, and we're just going to hit OK. And then we go back to element attributes, and since we want to do these in a certain order, we've got DE up next. We go there, we go through nodes, we're going to click node number 2 to node number 3. If you also define your nodes the same way I did, then your nodes are also going to match up the way Dr. Tuan had it and the way I have it. Let's go back here. Number 3 is EF, so we're actually already in the right one. Go to 3 through nodes. Click, apply, OK. The next one we're going to want to do is FB. So I think that is, yeah, we go back to this first one, make sure I'm actually recording. Yes, I am. Okay. Yeah, go back to the first one that we were using. Click OK. Through nodes again. We've probably already done this before. Click 3 and then 4. Yeah. Apply. Okay. So we've got node number 1, 2, 2, 3, 3, 4, and we got 4, 5, which is FB. 4, 4, 5, and then 4, 6. So 4, 6 is going to be FG. So we click OK, and we go to through nodes, and we click 4, 6, apply, OK. It looks kind of off, like it's slightly raised. That's odd. I'm going to take a look real quick. Turns out I actually defined node number 4 slightly below. You might have caught this if you were observant, but no number 4. If we go right there, we click. So yeah, no number 4 I had defined as 481.40, which would be 481.44. So if we click apply, click OK. Hopefully I didn't mess that up. But yeah, that should fix that. I understand that my elements are no longer showing up. That's an issue that I've had, but we're just going to continue on with our elements, defining our elements. So just double checking which elements I already have. Nodes and attributes. So we've got element all up to element 5. Again, we've got 1, 2, 2, 3, 3, 4, 4, 5, 4, 6. And we're going to want 6, 7 for our last one. So although it looks a little bit odd, I think it should be okay. So last one, we're going to want GC. And we've got through nodes. Click number 6 first, and then click number 7. Click apply. Click OK. So I want to figure out why my elements aren't showing up. All should be fixed. If you are wondering how to do that, I just looked it up. You go to plot, you go to elements, and it just popped back up for me. So there you go. So now that we have our elements defined, we can continue on. Now that we have our elements defined, we can go to loads, and go to define loads, apply, structural loads, and then displacement, and we're going to do on nodes. So again, what we did with the truss. Oops, I do not want to be doing this. I want to do a box. So choose a box around all of these nodes. So we've got all of them selected. Click OK. And we're going to want to constrain UZ, ROTX, and ROTY. With a plane frame, we can have bending about the Z-axis. That's just usual moment. But since this is 2D, can't really have any bending about the X or the Y or rotation in like the traditional sense. So we only want UX, UY, and ROTZ for our global stuff. And we're going to want to click double check right here. And for this one, we just want displacement value of 0. We click OK and click OK, and you're going to see the constraints are there, which is nice. So now to put in the other constraints that we need. For the bottom ones, you're going to know, or if you look at the drawing, you're going to realize that we've got fixed supports on all 3 of these guys. So we click apply, or we click OK, and we're going to want to fix it. So we just click the remaining ones that are applicable. So UX, UI, and ROTZ, which weren't clicked. Also set those equal to 0. And those are going to pop up as well. Can't really see because it's kind of a mess. But yeah, so we've got all of our boundary conditions set. So I'm pretty sure we're on the loads now. Okay, so for this next part, we're going to want to go to back into apply structural. We go to pressure. We go to on beams. So I already did this part, but you're going to want to click on the beam and you click OK. I guess I already did it, but you click on the beam, click OK. And so for this one, he goes pretty in depth, probably like a 5-minute discussion on why he's doing what he's doing. But if you want any of that information, you're probably gonna have to get it from him. Anyways, he puts a load key of 2 in there, and since we're trying to apply this pressure normally or normal to the surface, and it's 1.2 kips per foot, and we're trying to do kips per inch, and it's at that angle, whatever angle it's at, that breaks down to a 0.08. So let me just go ahead and put that in there, and you'll have what I have, which is this normal pressure to this beam. So now we're going to want to have another pressure applied. So we go to on beam, you go to OK, like that. And for this, you're going to want a load key 3. I'm pretty sure this just identifies a new load. And you're going to want to have it going in the opposite direction as the other one and have it be negative 0.004. So that's half of the other one. Again, not going into too much depth here as to why, but this is what he did in class. So. Okay, and then to finish off this beam, or this structure, we're gonna want to click this one, go to OK. We're gonna want load key 2 again, go to 0.08. Again, on the positive direction, click OK. And you see same type of thing going on that side as the other. And then to the tangential one, we go to OK. And we're going to go to load key 3. This is something that he messed up in class, but went back and fixed. And this is going to be a positive 0.04. The other side was negative. We want this one to be positive because instead of going from I to J, the last one, we wanted to go from J to I, but this one, we want to go from I to J, so that's positive. I to J as in defining a vector from I to J, just to clarify. So we click OK for there, and we've got that. Just to make sure, let's double check with his. To check, we go to list. Oops. We go to list. Oops. I'll fix this. Right. Lucky me, my file crashed and I've got to restart. So I'll be right back with this one. Okay, so I've got my geometry drawn out again. I put all the elements back in with the right section. So I'm just gonna again take it all back in while I finish this up. So define loads, apply. I'm just doing the boundary conditions right now. So this might be a little bit redundant. Sorry about that. Click OK. Easy. RTX and RTY. Yes. Then again on this, I do box. Bottom ones are fixed. So let me go to OK. And just choose all of these. Click OK. So I've got that. And now we can go to pressure on beams. You go to pick this one. Click OK. You go to load key 2, you go to 0.08, apply. I'm going to do it in the same order he had, though I'm not sure why he did it in that order. Go back, load key 3. Since we're doing it from J to I, we're going to do negative 0.04, like that, apply. Back to beams, click on this, okay. Back here to 0.008, nope, 0.08, click OK. We go back to beams, go right here, click OK. we'll do load key 3, and since we're drawing it from the I to the J direction, we can just do positive with that. And then I think this is where I crashed at. So, for this, for load scenario 1, we click on this one, and since it's completely horizontal, we go to load key 2, and we go to 0.1 since it's 1.2 K per feet, but we want it in kips per inch. So we go there and click up. Okay. I'm fairly certain that is all that we need for loading, and we're just going to need to solve it now. Just to compare, we can go to list, loads. Where did he go onto this? Sorry, just comparing real quick with what he did. List, loads, body, surface on elements, on all elements. Yeah, so just real quick, comparing with what he has, I've got same thing. So got 2, 2, 2, 3. I'm looking over here. 2, 2, 2, 3, 3, 2, 3, 3, 5, 2. Okay, and all of these numbers in the real column also match up. So that's good, and we should be ready to solve. So yeah, what he does is now that he's got this all set up, I'm gonna go take this full screen real quick. He's got that set up. We're gonna go to solution, solve, current LS, I forgot what this stands for. And there we go. So, and then we go to general post-processing, and we go to plot results. We can go to deformed shape. And from what I can see, that looks like what he has. It's a bit blurry, but we can also go to right here. We go to list results. Again, same as trust. We go to nodal solution. We go to displacement vector sum. It's under DLF. Displacement vector sum. Okay. And just double checking. I do not have the same displacements as him. Or no, I do not. Let's see. So, I must have defined one of the nodes wrong. I'm gonna just stop it right there. Yeah, I did not quite get the same nodal displacements as he did, but perhaps you probably caught, maybe one of y'all caught my error. So yeah, I'll end it there. Yeah, let me know if you have any questions.